Hey guys, what's going on? So we're going to do a linear programming problem here for your reference. Okay, and we're going to do the problem on page 167 and number 22 in your book. So that's page 167 in your book. Okay. All right. So here it is. It seems a little out of focus here, but this is the problem. Okay, so let's get to reading. So an office manager is purchasing file cabinets and wants to maximize storage space. Sometimes this phrase comes at the end of the passage, but in this case they got right to it. They say they want to maximize storage space. So sometimes we want to minimize things. In this case we want to maximize something. And in this case we're going to maximize storage space. I guess I should keep reading the problem, but when I see that, maximize something, pretty certain I can jump right to making my master equation. But I guess it's probably best technique if we kept reading. But that jumped out at me. So the office has 60 square feet of floor space for the cabinets and $600 in the budget to purchase them. So two different things going on there. Square feet of floor space on the floor, and then money to buy some cabinets. Okay, so cabinet A, ooh, there we go, now they're getting to it. So we got cabinet A. In my mind, that's going to set up a cabinet B somewhere. But cabinet A requires 3 square feet of floor space, okay? Has a storage capacity of 12 cubic feet and costs $75. So there's a lot going on there. You got floor space, you got storage capacity, and you got money. Let's just keep reading, and hopefully the stuff will gel. Will start to separate itself. Oh, here's the next cabinet. Cabinet B. It's our other cabinet. Remember, we're purchasing file cabinets. So amongst all this floor space and money and storage capacity, we're looking for file cabinets. Okay, so requires 6 square feet of floor space, has storage capacity of 18, and costs $50. Here's a big, good question. How many of each cabinet should the office manager buy? Okay, so ultimately that's what we're caring about. Those are our two products. How many of each cabinet? Buying file cabinets. Here's cabinet A and cabinet B. So we're going to organize our stuff around these two, comparing these two cabinets. Okay? Well, so let's see. We can get to making our chart that we've talked about in class. And let's see where everything goes. Okay, so we've talked about how put your two products up here, cabinet A, or it's not always a product, I guess, but your two kind of things that you're comparing. Okay, cabinet A and cabinet B. And let's see here. We have now in our master equation, we're gonna maximize storage space. Now, how many of each cabinet should we buy? Well, we're gonna have an A plus a B, and we're trying to maximize storage space. So amongst this cabinet A, we want to find the stuff that's talking about storage space. So there it is. Storage capacity is 12 cubic feet. So if there's 12 cubic feet per cabinet times the number of that type of cabinet, and then the other guy gives you a storage capacity of 18 cubic feet. Always make sure your units are consistent throughout the problem, like we saw in that one problem, but this case they are. 18 cubic feet per cabinet times the number of cabinets you have of that. We should have storage space plus storage space equals storage space. Fantastic. What about down here? Now we got these other variables. We have 3 square feet of floor space. So let's go ahead and write floor space is this row, and another variable is the money. It's the cost, right? How much each cabinet kind of costs. Well, cabinet A requires 3 square feet of floor space, and it costs $75. Okay, well, cabinet B requires 6 square feet of floor space and costs $50. Okay, well, great. And remember, we're trying to make equations going this way, going across the rows in this setup. So if we set up our two master things that we're looking for, and then a couple different variables, a couple different details about those two different products, we can go this way with it to make our equations. Okay, and now the office has 60 square feet of floor space for the cabinets. So you got less than or equal to 60 for floor space, and they have $600 in the budget to buy them with. Well, here's the dollars. We got to be less than or equal to 600. And now these variables will come down the columns. A and B, and we have our equations now. We have our master optimize equation up here once we get points, and here we have our constraints. 3a plus 6b is less than or equal to 60, and 75a plus 50b is less than or equal to 600. And of course we can't buy negative amount of cabinets, so A is going to have to be more or equal to 0, and B, we're either going to buy 0 or more. We're not going to buy negative cabinets. So let's go ahead and now you want to label a graph, label your axes. I'm going to call this, and you label them with each of your products. So make one the A axis and one the B axis. I'll make this one the B axis. Okay, and so now let's graph these suckers. Well, the easiest way is to do it by intercepts because it's in standard form here, isn't it? So if we plug in a 0 for B, plug in a 0 for B, covers it up. A will equal the 20. And if you plug in a 0 for A, over here, this goes away. B will equal 10. And while we're at it, we can figure out what this other equation will be. Plug in a 0 for B. A will turn out to be 8. It'll be 600 divided by 75. And if you plug in a 0 for A, that goes away. You have 600 divided by 50. B will be 12. Okay, well let's get to work graphing this. Since we're dealing with 20s and stuff, let's just go by 2s. There's probably enough 1s here. Well, let's see, let's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there's enough to go by 1s. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We just made it. So here's 20. And going up, we'll go 2, 4, 6, 2, 2, 4, 6, 8, there's 10. Right up there. Okay. So A is 20 when B is 0, and B is 10 when A is 0, and voila, look at that. We can graph this line. Let's make it red. Let's go. Bam. And let's make the other line purple. Okay, A is 8. A is 8 right here, and B is 12 up here. Jabam. There's 8. Here's 12. We plotted those dots. Now, of course, A is positive and B is positive. That means we'll shade up above the A axis to the right of the B axis. If we rearrange this into B equals, it would be B is less than or equal to blah blah blah. That means B is less than, so you would shade down. And this one is the same. B is less than. Once we kicked all the stuff to the other side, if you want to think of it that way, B is down. I should graph like this, down. So look at that. Our regional area is in here. Okay, so that is our feasible region, and we now have this point, this point, this point, and this point. Okay, so we have 0, 0. We have 10, 0. We have 0, 8. And we have this point. So to get this point, we have to eliminate these guys. So we could go multiply this guy by negative 25 in order to cancel out the A's. We would have negative 75A plus 50B. Negative 75A. Where is that? There we go. Alright, negative 75A minus 150B. I'm doing my math right. It's less than or equal to negative 1500. And the other equation is as he is, 75A plus 50B is less than or equal to 600, and we'll end up with negative 100B is less than or equal to negative 900. Therefore, B should be well, you don't have to do the less than or equal to. Actually, you can't do that in elimination, so just pretend it's equals 9. Okay, when B is 9, so that's something comma 9, we can substitute it back in, and we will get substituted back into here, and once you do that, you'll get a 2. Okay, so just trust me, because of time's sake, this is a 2. So now we go to our master equation, of course, and that's 12A plus 18B. So remember, that was storage space is 12A plus 18B. And so we say storage space is 12 times 0 plus 18 times 0 versus 12 times 10 plus 18 times 0 equals 12 times 0 plus 18 times 8, and versus 12 times 2 plus 18 times 9. And if you do that math, you should get 0, which is your min, and 180, and 96, and 186, which is your max. So woohoo, we found it. We should buy 2 cabinet A's and 9 cabinet Bs.